Okay, so we talked about the earth layers that we live on the lithosphere, on the crust of the earth. We also talked about plate tectonics, of how the earth was once Pangea and we moved apart over time. And that was because of how the plates move. And we had different type of boundaries. We had convergent, divergent, and transform. Then we talked about earthquakes, as well as we talked about the rock cycle. Now we're going to talk about volcanoes. So we're going to compare magma and lava. We're going to locate volcanoes and back to plate boundaries, as well as we're going to explain how a volcano has an effect on the lithosphere. So volcanoes. Well, Miss Cheek, what is a volcano? Well, a volcano is an opening in the Earth's crust through which molten rock, gases, and ash erupt. That means basically to leave out. Okay. Also, the landform that develops around this opening. So, as you see here, we have a little hole that has some smoke coming out of it, but then we have this cone or type shape where we see as the structure. Now, why do volcanoes form though? Like, how they even get here? Well, volcanic eruptions occur when magma rises to the surface. Now, let's put this into a thing. We can have water boiling on the stove, right? Let's throw some pasta in. And after a while, when the pasta stops cooking inside of the boiling pot, the water runs over. You start seeing the foam and the white and the bubbles all at the top, and it's running over. And the reason why it's running over is because it got too hot and it rises to the surface. So that's basically how volcanic eruptions are. So it occurs when the magma rises to the surface. Now this will happen when the asthenosphere melts enough to flow. Okay, and there's three things that can cause this. The first one is decrease in pressure. Second thing will be an increase in temperature. The third will be an increase in the water in the asthenosphere. Okay, so we have valleys, then we have the hot spot. Okay, and then the subduction zones. So where do they form at though? Like, we know they're here, but you just told me how they can possibly come. Now where do they go? Because we don't have no volcanoes here in North Carolina. Well, most volcanoes occur at divergent boundaries, convergent boundaries that have subduction zones, and then the hot spots. Volcanoes at divergent boundaries. So what happens here, divergent means divide. Divergent means divide. So this decrease in pressure pulls apart and lets magma rise up. So as you see here in this picture, you see how the earth is pulling apart and magma is coming up. These right here are called fissure volcanoes, and they're located at the Mid-Atlantic Ridge and Great African Rift Valley. Okay, so here's divergent, and I gave you an example here at the Great Rift Valley. So you see how it's kind of down. Remember how our fault lines, we talked about fault lines. So now that the ground then decides to divide, magma decided to rise, and this is what causes those. So you also said, Ms. Cheek, that it happens at the convergent boundaries, and it has to be around your subduction zones. Yes. So let's understand subduction. So subduction will increase the amount of water inside the asthenosphere, basically, which means it lowers the melting temperature. right? So let's just say you do have a pile of boiling water, but you pour cold water in it. It's going to calm that water down a little bit. And so at denser oceanic crust, obviously it's near, as you see, it says oceanic, obviously near ocean, it melts into magma. So the crust is pushed lower and melts into magma. So when the continental, which is the crust, and the oceanic plates converge, a volcano forms then on that land surface. So here's the best picture. You see how it's near water? So some of the oceanic crust and the continental crust made this. This is how we get the volcanoes on land. Where two oceanic plates come together, um, it makes a volcano island. So imagine and think about like Hawaii, a lot of volcanoes there. We also have a lot of volcanoes that are just there in the middle of the water. Okay, so here's some. So here's one in Indonesia. One of the biggest ones that we have that is near us is Mount St. Helens. Okay, so look at Indonesia. It's like, hey, it's just there. Well, remember again, the oceanic and continental crust causes these hot spots. Well, you talked about these hot spots. What are these hot spots? Sometimes volcanoes occur at places that aren't plate boundaries, right? And we call those things hot spots. Hot spots is basically where the hot magma rises from the Earth's mantle. Magma escapes where the crust is the thinnest or the weakest, right? So, can you imagine like having a bump on your face? Well, once the bump is at the thin spot, you barely touch it and it pops. And then you got some bumps that's like under the skin, it takes a while to pop. Well, this is where it's the thin. You can barely touch it and it pops. It starts out as a solid, then it melts and reaches layers of the lower pressure. Okay? So, example of a big hot spot, y'all know this. Why, look at it. It's really light. It's by the oceanic. So, this is where you do have some, but these are the main volcanoes. But there are four types of volcanoes, and you got to know these four types by looking at them. We have shield, we have cinder cone, we have composite, and we have fissure. Well, shield volcanoes come from runny lava. Okay, when science term we call that low viscosity. Okay, that has a tendency to flow distances before hardening. They generally have quiet eruptions. So this one isn't something that says like a big boom bang. So it's just basically like a volcano and it just decides to drip. Okay? So volcano has a broad base and gently sloping slides. So again, broad base, pretty wide, gently sloping slides like this. Okay? Less explosive. It doesn't go flying out, it just runs. Okay? Now it runs with black, runny lava made up of layers of lava, and this would be more like the volcanoes in Hawaii. So here's an example. You see how it's kind of flat, has a little hole in it. They just kind of run out from there. This is the one that is active inside Hawaii. Now, cinder cones form when molten lava is thrown in the air from a vent. Okay, so it does have a vent on top. As it falls, it breaks into fragments called ash or tephra that harden before hitting the ground because it's so hot. Then when it hits the atmosphere, it makes these hard fragments. So the ash and tephra make cone-shaped mound. Okay, they are smaller than most types, but they erupt explosively. Like this is that bump that you pop and it go everywhere, or like you ever pop something that's in a bag and it just kind of just you step on it and it goes splash. Ketchup packages how you step on it and it will splash everywhere. Magma is thick, and which allows pressure to build up. So this is a little bit harder. It's not like the other ones to talk about. It kind of just, you barely touch it and it just pops out. No, this one right here, it takes a little bit of pressure. And this one comes with a felsic violet color. So center cones look like this. Your typical volcanoes. So it's just like more like a cone shape, and it goes out like this. Here's some more. They got some in Iceland. This is a very, very pretty picture of one. All right, composite, or sometimes they're called stratovolcanoes. Okay, so from form alternating eruptions. Sometimes it's quiet lava, and with explosive ash, the layers build up and make a moderate size. This is the most common. So a lot of times when we have volcanoes, this is the most common. Their layers is made of ash and tephra again and lava, and it's about a medium color. So here's the one in the Philippines. This looks just like a mountain, right? This is your typical size. Like, hey, oh, that looks like a mountain. Nah, those are just volcanoes, bro. As you look over here, they look like mountains, but those are just volcanoes. These are in the Philippines, and the Philippines does have active volcanoes. So here's another picture of it, so you can see from a top layer how little hair almost got like snow and everything on it, but it's pretty much not really like snow. Some of it is the remaining ash. Some of it can be due to the cold weather. But as you see, these are the most common. Our last one is the fissure volcanoes. They form in long cracks where the plates are pulled apart, right? So plates are pulled apart, that's divergent. And they pulled apart near other volcanoes. So what happens is you may have a cinder cone or shield volcano, but then you have the ground kind of opens up, and this is where they pop in at, okay? Fissure and lava plateaus. Well, when lava flows from giant cracks or fissures along the entire length, sometimes it's very long. That whole thick, mostly flat layer is called a lava plateau. So again, we have these two volcanoes here, and blah, the earth cracks a little bit. That little thing of streaming lava is called your lava plateau. So here is a picture to be able to identify the difference and see how it actually flows, okay? So a composite, remember it has a cinder cone, but as well it has lava flow. So you see the shape of it, you see how magma comes, but it also has the little road. So we have the cinder cone, remember that kind of comes out like how you see it, cinder. And then we have the shield, and you see how the lava just flows off of it. So we have some that's just going to explode. We have the composite that has kind of both of them. And then we have the shield where the lava kind of just goes about its business. So now here's another one by looking at the fissure. So again, as the ground opens up, the lava kind of puts in between. So a lot of times we see on the movies and the lava's running down and the ground opens and lava happens. That's your fissure. So we do have a dome-shaped volcano, which kind of brings it again. Remember, it comes through the vent, comes out like a big old shot up explosive. We have the ash cinder, and we have the caldera volcano. As you see, like it's an old one at the top, so it kind of makes a hump like this one. So when the old collapses, that's what happens. Then it kind of fools up later on with a little pool of lava or whatever. So remember, we have one, and it's Mount St. Helens, and that we have our biggest one is in Yellowstone. Okay, if that ever goes off here, we are over here, and they never finished connecting North Carolina. We're over here and more right there where the red dot is. If that goes off, there's going to be ash that kind of takes this. As you see how it says the lava creek can go that far out. So, I mean, our ash will have it. We can breathe, but everybody is in my red thing is going to be a little bit messed up. So Yellowstone National Park. So here is a cross section of a volcano. You have to understand this, so please pause the video. You gotta pause and draw. Okay? Pause and draw. I have to see this inside of your notes. So we have the ash cloud, we have the secondary vents, we have the throat, we have the main vent, it's also known as the conduit, the magma chamber, this right here are those little packs. Um, this is on the outside, but these will be your layers of lava and ash, the lava flowing, the crater that happens, the secondary vent, and again, the main vent is the big hole at the top. You need to pause and draw this and label this, okay? So I mentioned this earlier, but how does a caldera form? Well, volcanoes pressure, it builds up. The volcano releases large amounts of lava, okay? So I'm showing you, build up, releases a lot of lava. Now, as the lava is released, the volcano mountain begins to collapse and make a concave shape. As you see it, after it blows up, it kind of sinks in. Then, at the very top, it fills up with water, and if it ever erupts again, it can be like a little pool of lava, but most of the time, it makes lakes and stuff. So here's one in Oregon State. We call it the Caldera Lake, which was basically, again, a volcano that erupted and fell in. So the Ring of Fire, I know y'all heard of this, but this is the Ring of Fire where volcanoes around the Pacific Ocean results from subduction of oceanic plates, okay, lighter than that. So this is why we have volcanoes, as you see here, on the outside of the water where it hits the land. That's why Japan is nothing but volcanoes. They have like some of them that are active that can just go off anytime. That's why Philippines, the ones that are yellow are very active. Okay, so with that being said, that's called the Ring of Fire. What happened? All these volcanoes went off at one time. That's crazy.